Now that we have some better idea of what shared memory is and memory passing is, we're going to give some specific examples of how basically IPC is implemented inside of Linux. So first thing I want to talk about, right, is this is going to be PostX, right? And actually this section talks about PostX, also talks about message passing in another operating system. We're not going to really go too much into detail. Maybe what I want to talk about here is basically the shared memory system under Linux, right? And so PostX, right, is the name of just the standard library. So we're going to take a look at this. Basically the way it works is by creating kind of a virtual file. As virtual file becomes memory mapped. So actually just to kind of give you guys maybe a little bit of an idea really quick of what that means. So there's this kind of general idea of memory mapping stuff. And so somehow what it looks like is this, right? So normally I have kind of my main system memory, which looks like this, right? It goes from 0 up until, I don't know, 1684, whatever. There's like some really huge number, right? So whatever. Well, one thing that people do, right, is basically have this idea of memory mapping, where memory mapping is to say, okay, you know what? Instead of just saying that, oh, this is, kind of, my main RAM memory, right? And this is, right, there's addresses from 0 up until whatever, right? So just saying that, we'll say there's the following. Some of these are somehow special, right? And so, like, imagine I just highlight this region here, right? And this region could map to something like, for example, a VRAM, right? It was one kind of classic example. And what this is actually doing is it's saying, you know what? When the user's program wants to go and wants to use an address in this interval here, right? When I want to do some pointer arithmetic in there, instead of, acting on the RAM memory, right? Instead, go and modify your VRAM, right? So go to your graphics card, right, and change some little graphics memory, right, that's associated with it, right? And so that's the idea kind of memory mapping something, right? The idea is that there is maybe some outside resource, right, some outside memory, right, and we want to basically make it show up as if it was main system memory, right? That way our program can try to basically manipulate it as if it was, main system memory. So this is the idea of memory mapping. Here, the way Linux will end up working is we have basically, you imagine you have a file on your hard drive somewhere, and that'll basically end up being memory mapped, right? So it's like, well, if my program goes and it edits this little bit of memory, right, just thinks it's an address, really what happens is it ends up mapping or changing into, something that's really a file behind the scenes, right? So you can imagine perhaps that, right? So that's the idea of memory mapping, right? Basically say, oh, I have a ton of these addresses, that are available to me. Instead of having them all point to, my main RAM memory, I can instead make them, point to something else, right? Some other resource. And so then my system can manipulate it without using kind of any special library, any special syntax. And so that's how Linux will work here in terms of shared memory. So we're gonna go through an example, right? It's gonna be a little bit long. Well, it's not going to be that long. It's going to be 2 slides. Okay, maybe that's long, depending on how long I talk. But there is basically 4 main functions to look for, right? Which are going to be these here, right? So SMH open, ftruncate, mmap, SMH unlink. So SMH is basically shared memory. So that's basically to open up a new kind of virtual file that can be available in shared memory. Is basically what that first function is doing. The second function, ftruncate, is basically to go to a file and set its size, right, to make it a certain length, right? So we need that basically to size what this is, right? The first function there creates this file over here, right? It'll end up being kind of a virtual file, meaning that our code will pretend it is a file, but it doesn't actually show up as a file kind of in your file system permanently, right? You're not really opening up something to read or write, right? You're just kind of opening up a virtual file, because in that virtual file then you can memory map it. So the third thing here, right, is mmap. Mmap is memory map, right? So that's the thing that creates this arrow here. So maybe, let's see if I can maybe I should label these, right? So this is maybe 1, 2, 3, right? And so 1 creates the file over here, right? 2 resizes it. 3 creates this memory map linkage, right? SMH unlink is basically make that file go away, right? So at the end of the day, if I X that out, right, release it back to the system, how do I do that? It's SMH unlink. So yeah, these are the 4 kind of main functions to be looking for in our examples. So what we're going to do is we're going to make something that looks a little bit like producer-consumer. I labeled it as producer-consumer, and then I had some regrets right now when I was starting to go through these slides, because it's not quite producer-consumer. Really what it is one process that creates information, and then another process that uses that information somehow. So there's kind of 2 programs here, right? So you can imagine I'll have 2 processes kind of running side by side. Up top, right, I have kind of all my standard includes, right? So I have my my standard I/O, right? My standard library for memory management. I have string I/O, right, for dealing with strings. I forget that this is function control. I forget what that we need that for. This is obviously for the networking stuff, and this is for some of the structs that we need. So yeah, we need to bring in all those. Okay, so now we have kind of our body of our program. So let's walk through this kind of line by line. So starting at the top, right, we have our size variable here, right? So that's me basically saying, okay, what I want to do basically is create this pool of shared memory. Right? We want to demonstrate shared memory here, right, under Linux, right? So I need to decide how big my share is, right? So the graph, right, how this works, right, is I have my 2 processes, right, running side by side, right? So this is P1, P2, right? and they're both kind of allowed to access the same thing, right? So right now I'm basically working on P1, right? We'll call this P1 over here, right? Consumer will say this over here is P2. Jumping back over here to P1, right? I need to basically decide what is the size of my shared memory, right? This is my memory here. How do I decide the size of it? Here I'm just arbitrarily picking 4,096, right? So that's kind of the size of this thing here, 4,096. There you go, close enough. Okay, so that's my shared memory there. Then I have to have a name on it. This is effectively a file name, right? So what we need, right, is we need a file in order to memory map that file. But we also are basically having a virtual file. We're not really creating a new file just for writing and reading, right? We don't want to have something that's really sitting on a disk permanently. And so when we do that, though, we still need to have a name for it. Right? We need to have a name because otherwise, how can we access it, right? And so that's here in this name variable. So this thing here, right, you can tag it as though this is OS over here. And later on, when we go over here, you'll notice it's the same thing, right? We're referring to the same name. That's really the way they both get access to the same shared memory, right? Is via that one name. All right, so back in the producer. Next thing we have are our two variables here, the whole strings, hello and world. What that is basically the data we're going to be putting into this share, right? So what we're actually going to do in this program is that our P1, right, our P1 is going to transmit this information, right? So it's going to transmit, hello world to the to P2, right? It does that by basically placing that inside the store, right? So this text shows up over here, right, inside the store, and then P2, right? P2 is basically going to go in, right, and see the text that's in the store and then print it out, right? So we're just kind of taking text, putting it in there, taking it out, displaying it, right? So that's kind of our flow here of our program. So our message there is in those two variables. Next thing we do, right, is this variable here, SMHFD. That's basically the file descriptor, right, for the actual, that virtual file I'm creating, right, that shared memory file that I want to create. I just need basically that integer to keep track of, what is the file descriptor, so that later I can do things like print to it. So I'll create that. Well, not printing directly, but you'll see in a second. Next thing I have there is PTR, right? So PTR is actually going to be our pointer into shared memory, right? So if I were to diagram this again, right, I would maybe say, okay, my variable there into that space, that thing is called PTR, right? That's going to be my pointer kind of traverses the shared memory. And I'll have that PTR variable both here and then later on kind of in my, well, if I want to, I can have it over in my consumer. All right, so rest of my program here. The kind of the heavy lifting is done over here. This stuff down here is kind of my once I've set everything up, how do I manipulate that So first thing I have here, right, is this is SMH open, SMH FD equals SMH open. So basically that's the point where we're opening our virtual file and we're saving a link to it, right, in that variable. So the FD again, right, stands for file descriptor, right? So that's kind of the ID number, right, of the virtual file I create. And so the syntax here, right, is really to say, okay, you know what, this is the name it's going to be, right? So my virtual file will have that name, right? And this virtual file, right, is going to be kind of shared memory, right, that other people can access. So I'll call it that, right? I'll call it OS. I'm going to have these two flags here, right? So the first flag over here means, yes, you should create the file if it doesn't exist, because obviously it won't. And this one is, set it open so I can do both reading and writing to it. Last thing over here, right, is going to be for basically the file mode, right? So this is a Linux command. Basically that value there is basically to enable, any user to read or write from it, right? So we're making this kind of a global piece of memory that anybody can access. So after this line is run, right, after we get to over here, basically what happens is we have kind of this virtual file in memory called OS, right? It's available for reading and writing by anybody, right? And the OS will have created it if it doesn't already exist. All right, so next step here, right, is to run our ftruncate. Ftruncate is basically a look at the file and set it to be a certain size, right? Initially, it doesn't exist, right? So it's going to be a size 0. Here, we're basically going to fill it up with 0, so it's 496 bytes long, right? So that size variable had that value in there. And ftruncate basically is if it looks at a file that's smaller than the number you pass in as a parameter, what happens is it basically makes it bigger and pads it all with zeros. Okay, so now we'll have kind of our working space created. Last key line here is mmap, right? So that's memory mapping, and so that's basically where we're going to say, okay, you know what? I'm going to take that file that I've created, right? That shared memory file. I'm going to actually, bind it kind of to a specific address in memory. Okay. So over here, right, you can see that I'm basically mapping this file over here, right? The file descriptor is being passed in. I'm going to map it as shared memory. And I'm going to allow people to write it. I'm going to allow me at least to write it. This is how much memory I want to share. And over here, right, I basically don't care where in memory it ends up going. So my share, right, is referring to, where do I put in memory over here, right? I need to basically pick some offset in system memory, and that's going to be where my virtual file shows up kind of mapped to main memory. I don't really have a preference for where it ends up in memory, so I have this first thing being a 0. I know there's a last 0 there, and I forgot again. Whatever it is, it's probably not important if I forgot what it is. I think that's a default for probably for permissions or something like that. So you can just leave that as it is. All right, so at the end, right, what you get is this variable here, PTR. So what PTR is that pointer, right, into my shared memory, right? It's a pointer into my working space where I can do stuff. So that's really what I need, right? Now that I have that PTR, right, which is mapped, which is using basically mapped to memory, right, which is mapped to a file, right? Once I have that, right, then I can basically do my printfs there, right? So it's sprintf because of the formatting. It doesn't really matter though. Well, I guess it does matter, right? Because what I need to is basically I want to print to that shared memory location. I want to print to where PTR points at. And so my sprintf variable, right, that's taking PTR as a parameter, right? And so that's saying that, okay, that message, I'm going to write it here, right? And so this first line is basically saying that I'm going to write that text hello, right, coming from the message 0, right? Message 0 is defined over here. Take that text and print it into the to that location of memory where the shared stuff is. So that kind of gets filled in, right? And then I basically I advance my PTR, right? So PTR is basically a pointer somewhere in my memory. Well, if I go there and I print some text, right, I need to basically move my PTR forward past the stuff I've already written. That way I can write more stuff, right? And so that's what that line there does with that plus equal. Then I do another print, right, basically to print out the second message, right? So I go and I print the world as well, right? And then I can move my pointer as well. I don't really need to do that because not going to write anything else there, but it's just kind of a best practices thing. So at the end of the day, once this is run, right, the way the world looks is that I have basically a virtual file, right, that's out there, right, it's called OS, and it contains now the letters hello world, right, so that's out there, and it's available for people basically to access it, to read it, and write it. It's in shared memory. So how do I connect to that? Now I can go kind of the consumer side, and some of the stuff here is similar, right, so we have the same kind of includes, we have kind of the same variable there, store the size of the buffer. We already talked about this is the file name, OS, the file descriptor, pointer, right, that's all the same. Then here, right, we basically are opening it up, right? So we're doing the SMH open again, using the same name, right, the OS, and here, right, we're doing read only, right? And we're saying the privileges on that are basically going to be, anybody can read or write from it. Anybody can read or write from it, but I'm going to basically restrict myself here, right, to being a read only access. So I have that open, right? I have now my file descriptor that's available, right? So I now know, basically, I have a number that indicates, this is how I go and find that file later on. And then I do mmap, right? So this is basically the same, right? So this line is identical to the previous one, with the only exception being this over here. So here, as a consumer, I only care about reading it. I don't care about writing it. And so here I'm passing in basically the request, right, to do read-only privileges, not no writing. So that's the one difference there. So then I have my PTR, right? So my PTR, all of a sudden, right, it becomes basically this new variable, right? It's a kind of a new PTR, right? This is a PTR under the second process. And it's again going to be a pointer, though, to some place in shared memory, right? To the beginning of that shared memory space. Once I have that, basically I do a printf, right, reading from PTR, right? So I go and basically say, I'm going to print out this data, right? Print out what's ever there. And so that text that I copied over there earlier, that's the stuff that will be basically read from this printf call, right? Because I'm going to that one PTR, and PTR is pointing at this memory mapped location, right? This memory application is referring to a shared file that everybody can access, right? So I print out that stuff that the other person wrote, and then I'm good to go, right? Now I can, at that point, basically unlink and throw away the file that I had just opened, right? Because I don't need it anymore. I've already displayed everything from it. So there you go, right? That's kind of a very quick overview, right, of how you kind of access this stuff inside of Linux, right, as far as having the shared memory using PostX. As one further example, I'm just going to do this really briefly. This is Mach. I should look at how these things are pronounced, but I don't because I forgot. So this is kind of an OS, right, that was coming from, I believe, from Apple, basically. I'm not going to go through ton of syntax for this. Or what I have this here is basically just a little bit more discussion on kind of the mailbox approach. What we saw earlier, right, is direct communication. Those two processes, well, what we saw earlier is shared memory, right? Excuse me. Right now we have, right, is message passing, and this is, we had kind of two classes of memory passing, right? We had direct communication, indirect communication. This is actually indirect, right? So this is basically where we say I have a mailbox, right? That was the system that looked like this, right? Where I have basically my two processes running side by side, right? And then both kind of access one mailbox, right? So rather than talking to each other directly, there's an intermediate. And so this is what Mach does. So you can see basically this is the format of the messages over here. So you can see, right, we have basically some header data, right? The header has obviously all this stuff, right? How long is the message, right? And then all the stuff in the message, right, falls in the data region afterwards. So that's all kind of very, very typical stuff. That's just how a message might be structured in any operating system. Then you have standard stuff, right? Yeah, like receive, send, receive, RCP, allocate. Then you have you here in this OS, right? Basically, instead of calling them mailboxes, they call them ports. Same thing, though, right? Those terms are a little bit. They basically mean the same thing. So, Send and receive, we've already seen a little bit. The one new one here is basically RPC, remote procedure call. We'll go into that later. Basically what that is a way to call functions remotely from another computer effectively, right? So it's like, or from another process running, right? So sometimes I just want to reach across and, I don't want to give this person information. I want to actually tell them to run a function, right? And give me back the result. That's called an RCP, right? A remote procedure call. So we'll talk about those more later. Port allocate is basically just to set up the ports correctly. So last note here, right? So ports, right? The advantages, right? And we talked about this already a little bit. Is basically if I have a port or a mailbox, right? I can have multiple people leaving messages there, multiple people picking up messages, right? That's called N-to-1 or 1-to-N, right? End-to-end means I have multiple people putting in, multiple people taking out. The thing where I mentioned where I said that maybe you could think about copying the message and duplicating across, that's called the broadcast, right? And that is actually a nice feature. And we need it kind of in some environments, but here we're typically okay. We don't need to duplicate stuff. All right, so hopefully that gives you a little bit of a better idea, right, of basically how IPC is implemented in a couple of operating systems. So yeah,